Here we have another special case problem in which you need to generate the side view in order to complete the solution. It's a rectangular lamina problem which appears as another rectangle. Let's note down the data and see how we are going to solve this problem. Now in this problem we have a rectangular lamina of 20 by 25. So let us just read the question and understand where we are supposed to draw the plane figure. Here it is a rectangle. So since it's going to have unequal sides, we'll be able to draw the rectangle in two positions as we discussed in previous problems as well, right? So either you keep the shorter edge on the left side, or you can also draw the rectangle in one more way in where the longer edge will be on the left side. So this is one question that you need to answer, in which way you need to draw the rectangle, and the other question that you need to answer is whether you need to draw it on VP or on HP, right? So if you read the question forward, the next condition what says here is the edge in VP and the adjoining edge is in HP. Now all of you carefully read it again. It says that the rectangular edge is in VP and the adjoining edge is in HP. So you see here the edge is in VP and there is one more edge which is also in HP. So we usually used to decide where to draw the plane figure depending on where the edge is resting, right? If it is resting in VP, we used to draw the plane figure on VP. If the edge is resting on HP, we used to draw the plane figure on HP. But here we have a confusion because the question says the edge is in VP and the adjoining edge is in HP, right? So we have edge in VP and HP as well. So we can't decide where to draw the plane figure based on this data. Always remember, if you have confusions with pertaining to any one data, you go on reading the question and see the remaining data. You will have a clue in one or the other way in the remaining data to go ahead with the problem, right? So in this problem what we have, if you read the next data, this rectangle is tilted till the front view appears as another rectangle of 20 by 15, right? So here the rectangle is being tilted till the front view becomes another rectangle. So we have seen in the previous problem, right? So if the rectangle is rotated, it might appear as a square, or a square is rotated, it might appear like a rectangle. But in this case the rectangle is tilted such that it again looks like a rectangle but of a different dimension. The first position rectangle here is 20 by 25. So this first position. In the second position the rectangle is reduced in its dimension because it appears because of tilting. Tilting means we are going to give some angle to the plane, right? So this 25 is one which is going to reduce to 15, right? Front view means it is nothing but VP, that is vertical plane. So in the second position front view, if you want a rectangle of 20 by 15, I must have the original rectangle of 20 by 25 in the first position VP itself. So I need to draw the plane figure in VP. VP in the sense above the XY line, right? So now you need to answer which of this has to be drawn. Because it is a rectangle, you can keep shorter edge or you can keep a longer edge. Now see which dimension is actually changing from in the rectangle. 20 by 25 is changing to 20 by 15, which means that 20 is remaining as it is while 25 is getting reduced to 15 millimeters. It appears as reduced only when you give some inclination to that particular line or that particular plane. So here I am going to incline 25 means I must keep that 25 millimeters parallel to the XY line in the first position, and in the second position I can tilt it to some angle. I do not know that, we need to find that angle. Top view can be tilted so that the lamina is inclined in such a way that this dimension of 25 reduces to 15 millimeters. We need to draw this position of rectangle such that we have 20 here as vertical, that is a shorter edge, and 25 as a horizontal line. Now remember, when you draw the rectangle, you see, make sure that the rectangle is resting on the XY line itself, right? Because the problem says we have an edge in VP and the adjoining edge in HP. I'll come back to this in the later part of the question, but now remember we need to place one edge in HP also. If you say that edge is in VP, if you place that edge on the left side, that is sufficient, that will satisfy the condition of edge in VP. That is how we have the drawing procedure. Now if you want to keep one edge on HP also, the adjoining edge is simply this. The adjoining edge means the edge that is coming along with the edge that you consider. For example, here we have edge in VP. So if I have the left side edge in VP, the adjoining edge for that particular left edge are going to be 1 and 2. Two adjoining edges are going to be present, right? So 1 and 2. Which adjoining edge you need to select? You can select any of it. So what I'll do is I'm going to keep one of the adjoining edge on the xy line. So if I keep the adjoining edge on xy line in VP, it means that this adjoining edge is actually resting in HP, right? Because any condition with HP will be satisfied in VP. Here it says that the adjoining edge is in HP. Condition with HP, you will be able to see that in vertical plane. So this is the adjoining edge which will be on the xy line, which satisfies this condition also. So while you are drawing the rectangle, you draw the rectangle in such a way that the adjoining edge touches the xy line. Now if the plane looks like a plane in the front view, it has to appear as a line in the top view. Now all of you observe here, one more thing you need to notice here is that it says that one of the edge is in VP. If one of the edge is in VP, this is a condition with VP which will be satisfied in the horizontal plane. So in the horizontal plane, you must make sure that that particular edge, what we are considering, should be touching the xy line in the opposite plane. If edge is in VP, it will be satisfied in the opposite plane. So opposite plane is HP. Here you need to make sure that the edge that we are considering is the left edge. So this left edge should be touching the xy line. So the top view is going to be simply drawn on the xy line itself. Now the top view is going to look like a line. The first point viewing from the top will be D, and next we have A. So I'll write D outside bracket and A inside bracket. And then you have C and B, C outside bracket and B inside bracket. Next thing we need to do here is we need to incline this lamina, or in this case we don't have the inclination of the lamina. Instead they have given that the lamina is tilted till the front view appears as 20 by 15. So we already have 20 mm vertical here. It is going to remain as it is in the next position. But what happens to this 25 mm horizontal is that it's going to reduce to 15 millimeters, so that we get 20 by 15 in the second position. How can we reduce this 25 mm? As I already told you, this top view has to be inclined. If this top view is parallel, we'll get 25. If this top view is inclined, then this 25 will go on reducing. Till where I have to incline, I do not know. That is what I need to find out. So next data we know here is the front view is going to appear like 20 by 15. So we will construct a 20 by 15 rectangle in the second position. Now we have the new edges formed of new shape. We can name them in the same order. I am naming it in anti-clockwise, so you follow the same for every position. Now this 25 mm is reduced its length to 15 millimeters, and as I told you, this has to be inclined at some angle, then only this 25 will reduce to 15 millimeters. Now the next thing you need to keep in mind is the edge on the left should be kept on xy line only. So which is the edge on the left side here is DA. So this same point will be named as DA. So what happens to CB is we are going to rotate this top view so that we get some inclination. At that inclination, this 25 will reduce to 15 millimeters. So what is this inclination? I need to find it out. You simply drop a projection line from C dash and B dash. On this line, I need to get the point of C and B, which you can measure it using a compass. Keep the compass needle at DA and cut the arc on this projection line. So where it intersects this projection line, that point will be the new point C and B. Join them with the dark line. Remember, the plane should look dark in every drawing whatever you do. The plane looks like a plane in front view, it looks like a line in the top view. So plane and line are dark. Plane and line are dark. Find out this inclination. So when you measure this angle, you are going to get 53 degrees. So if you just have a checklist of the given data and see what and all we have done, we have completed a rectangle of 20 by 25 and we have kept one edge in VP that we have satisfied it here. The edge in VP is going to be AD and the adjoining edge in HP, the adjoining edge that we have selected is one that is on the XY line, that is A dash B dash or AB in the top view. You can write AB if it is in top view, right? And then we have tilted the lamina so that it appears as 20 by 15 mm in the front view. So we have done with that also. So if you go to the next condition, the edge in VP is 30 mm from the right profile plane. So which is the edge that is in VP? We have already identified it, one that is on the left side. So according to our drawing, the one that is on the left side is A dash D dash. So or AD if it is in top view. So this edge is at a distance of 30 mm from the right profile plane. So right profile plane will be found towards the right side from the viewer's direction. 30 millimeters from A dash D dash, you will get the right profile plane. So this reference line will be named as X1, Y1. What are we supposed to generate here is the side view, because we have in the question you need to draw top view, front view as well as the left view. The left view will fall on the right profile plane. So this is a right profile plane which we have drawn on the right side. Right profile plane, you are going to get the left side view, right? So you all know how to generate the side view. We'll do that, but before that let me just show you how this lamina is actually resting on VP and HP such that the adjoining edge is in HP. Now to generate the side view, you can draw a 45-degree line next to horizontal plane. Horizontal plane is below the line. So below the XY line from the junction of X1, Y1 and XY line, that is the origin, you can draw a 45-degree line. Use a protractor and draw a 45-degree line. So this angle of the line should be 45 degrees. Remember to use a protractor or a set square and draw the exact 45-degree line. Now we can draw the projection line from top view till the 45-degree line. I'll start with point A. Here I have point A, this point A, right? So if I draw a projection line from point A till the 45-degree line, it's going to meet at the origin, right? This is a 45-degree line where the line from point A meets, right? This has to be taken as a vertical line till it reaches A dash. So in this problem we have A dash on the XY line itself. So what does that mean? This point itself is going to represent the side view of point A, which will be named as A double dash, right? Go on with the remaining points. We'll draw a line from point B till the 45-degree line. This is point B, right? So these lines should be thin. So from point B, you draw a vertical line till it reaches B dash. Where do we have B dash? In the front view, we have it on the XY line. So from here, we'll draw a vertical line till it reaches the XY line. So where it intersects, that point will be this point will be the side view of point B. We'll repeat the same for point C. From C, if I draw here and then a vertical line till it reaches C dash. So C dash comes from here. So you can draw a horizontal line. Now where it intersects, that point will be C double dash. When we do the same for D, you can see here, if I draw a horizontal line from D, it touches 45-degree line over here at the origin. Take a vertical line till it reaches D dash. So this intersection will be the side view of point D. Join these 4 points, that will give you the side view. So this is the side view for the given problem. As you see here, I have told you in the previous problems also, when we go to right profile plane, this vertical line will be considered as VP and this horizontal line will be considered as HP. So in this side view, we will be able to see the conditions very clearly. As it says, one of the edge is in VP. So according to this side view, this vertical line will represent the VP. Which edge is on this vertical line? We have A double dash and D double dash. As I already told you, the edge that we have taken in VP is A D, right? So in side view, the point AD will be named as A double dash D double dash. That is what you see here. And the adjoining edge is in HP, which is the adjoining edge for AD. As I already showed you here, the adjoining edge will be the immediate next edge, right? We have selected the bottom one. So the bottom one from the drawing is A dash B dash, that is in front view, AB in the top view. So in the side view, it must be A double dash B double dash, which you can easily see here. In the horizontal line, you have A double dash and B double dash touching the XY line. This satisfies the conditions what are given in the problems. What and all we need to draw: top view, front view, left view. We have done with all three. You need to find the inclination with corresponding principal plane. That also we have found out as 53 degrees. The lamina is making an inclination of 53 degrees. And that gives the solution for the given problem and the conditions. For any doubts or clarifications, you can drop a comment or contact me through my mail ID.